Welcome back to another video, another lesson with Amanj. Well, today in this video, we're going to start a new chapter, a new section, a new topic that we never discussed about it in previous grades under the title of Trigonometric Ratios and Trigonometric Functions. Well, in the first section, there are like 4 or 5 ideas in one section that we need to take care of, like each and all of them perfectly, because from each one of these ideas teachers can bring questions. All right, so all of them are important, so one by one we go through in them. All right, well, the title of the first section is Trigonometric Functions and Trigonometric Ratios. We can just mention like this. Well, first of all, there are some information that we need to take care of them, that we need to know them in order to deal with the whole entire section that we face. Okay, so right triangle is a triangle that has a 90 degrees. This is a kind of right triangle that it has got 90 degrees, by the way, angle. So let me just bring my pen. All right. So here is the right angle. So basically, a right triangle is a triangle that it has a right angle. So the sides around these right angles are called legs, and the side opposite to it is called hypotenuse. All right. So hypotenuse is the side against right angle, and then we call these two sides legs of our triangle. Perfect. Hypotenuse is the side opposite to the 90 degrees angle. This is what we said right now. And in trigonometric function, pi equals to 180. Till now, we just consider pi as 3.14 because it was related to the area and perimeter of like circle. But in trigonometric matter, we will say that pi equals to 180 degrees. It's an angle. Perfect. So in that triangle, take a look at it. Let me just check the video whether it works perfectly. And yes. So the triangle, as you can see over there, it's a right triangle. Side AC or CA, doesn't matter how you are going to name it. So AC is called hypotenuse regarding to angle A. Regarding to this angle, which is angle A, AC is the hypotenuse. Why? Because it's exactly in front of the right angle. And then the opposite side, we call it opposite side, all right? And the side next to it, which is in the base of our triangle, is called adjacent, next to the angle A. So according to this angle, we just name these 3 sides, because we need to know how are we going to name the sides that we need. All right. The next thing that we need to take care of it is the most important slide is in this PowerPoint, by the way, in this lesson. Well, try to focus on it because there are a lot of things regarding to this slide. All right. So trigonometric ratios regarding to angle A. All right. We have got 3 main trigonometric ratios: tan, sine, cosine, that you will deal with them a lot during grade 10, 11, and especially in grade 12. All right. So, of course, each one of them has its own definition, and there is a code regarding to memorizing their formula as well. For tan of A, take a look at this angle. Angle A, tan A equals to the opposite side over the adjacent. Opposite side over the adjacent. Of course, in the exam, instead of opposite and adjacent, we have got numbers, numerical example. All right. So, as a code for tan A, we said that it is equal to TOA, TOA. O stands for, T stands for tan, O stands for opposite, and A stands for adjacent. So TOA means opposite, tan equals to opposite over adjacent. The second one is sine A. Well, for sine A, we will say that it's opposite over the hypotenuse. Opposite side over the hypotenuse. So, therefore, we have got this code. So, sine equals to opposite over the hypotenuse. And the last one is cosine A. So, regarding to this angle, which is angle A, cosine equals to adjacent over the hypotenuse, which is CAH. So CAH, C-A-H, it stands for cosine equals to adjacent over the hypotenuse. Perfect. There is a note here. It says that the opposite and adjacent sides change when we change the reference angle, but hypotenuse remains fixed. يعني simply, based on the angle that we are dealing with, adjacent and opposite sides change, but hypotenuse will never ever change, because it's exactly the side against to the 90 degrees angle. That's why hypotenuse doesn't change, but opposite and adjacent sides based on the angle are going to change. All right. So let's go to the next slide. I hope that you understand this slide. So there is a numerical example here. It says find the 3 trigonometric ratios for angle A in the given triangle. So where is angle A? We need to find it out. Where is angle A? So regarding to angle A, this side is going to be opposite. This is going to be adjacent. And here is going to be the hypotenuse. All right. So remember the trigonometric ratios. The first one was tan. The word that we used was TOA, which is tan equals to opposite over adjacent. What is the measure? What is the length of the opposite side? 4 over. What is the measure of the adjacent one? 3. So 4 over 3. Just write it in fraction form, or with calculator you can just turn it to decimal form. All right, 4 over 3. I guess it's equal to 1.3333, something like this, if I'm not mistaken. All right, how about, by the way, tan A, angle A. How about sine? Sine angle A, so it is equal to SOH, which is sine of A equals to opposite over hypotenuse. What is our opposite one? 4. And the hypotenuse one is 5. 4 over 5, which is 0.8. And how about cosine? So cosine A, angle A, we use the word CAH, which is cosine of A equals to adjacent over hypotenuse. What is the adjacent? 3. What is the hypotenuse? 5. So 3 over 5, which is 0.6 if you want to turn it to decimal form. This is how we are going to find out ratios, trigonometric ratios regarding to a right triangle. And I hope that this is understandable. Okay, the next question that might come is now regarding to angle C. Remember, we said that if we change the angle, opposite and adjacent will change, but the hypotenuse will stay the same. Right now, I will change to angle C. So angle C, it says find the 3 trigonometric ratios, of course. So tan C, sine C, and cosine C. So tan C. Now for this angle, this is going to be the opposite, according to name, opposite side. And here is going to be the adjacent. Of course, this one is going to be the hypotenuse. All right. So tan C, TOA, toa. Opposite over adjacent. Opposite is what? 3. Adjacent is what? 4. 3 over 4. 0.75. Sine C. So, opposite over hypotenuse. Opposite is what? 3. Hypotenuse is what? 5. So, 3 over 5. How about cosine? So, cosine, we had a word, a keyword, which is ka. Adjacent over hypotenuse. Adjacent is what? 4. Hypotenuse is what? 5. So, 4 over 5. This is how we are going to find out the trigonometric ratios regarding to a triangle. Next one. Okay. This is another, this is the second idea. Right now we are going to define what is the second idea of this lesson. Well, here there is a note before solving that question. We can use the values of the trigonometric ratios to find the length of a triangle. Okay. So how are we going to find it? This is actually not the second idea, the second type of question regarding to trigonometric ratios. How are we going to find it out? Like find the length of a triangle by using trigonometric ratios. For example, here, angle A is given and the opposite side. When opposite side is given, so either it asks for what? Find the length of the sides of the given triangle. So we need to find here and here. So if you want to find the adjacent, we need to use tan, okay? When the legs are given, When the legs are given, we need to use tan. Remember this sentence because I'm going to use these notes, these point a lot. If the legs are given, I'm going to use the ratio of tan to get the unknown thing. All right. So tan, the angle is 37. What was the definition of tan? It says that trois, opposite over adjacent. What is the opposite one? 8. What is the adjacent one? AC, let's say. The side AC. So tan 37, I need a calculator. Let me just use my student's calculator here. Okay, of course, I will take permission later on from that student. Tan 37, so tan 37 equals to 0.75. So 0.75 equals to 8 over AC. Give a denominator 1 to here, make a cross product. Okay, cross product. 1 times 8, 8. AC times 0.75, 0.75 AC. Divide both sides by 0.75. So that's going to be cancelled. 0.75, 0.75. This is going to be cancelled as well. So AC equals to 8 divided by 0.75, which is 10.6. So that's here it's going to be 10.6. Perfect. So right now we can use another trigonometric ratios in order to find the hypotenuse. Well, I'm going to go with sine. You can go with cosine as well. So sine 37 equals to opposite over hypotenuse, 8 over hypotenuse. I will write h instead of hypotenuse, which is AB. So sine 37, it equals to 0.60. 0.60 over, of course, 1 equals to 8 over hypotenuse. So if you just make cross product again between these two equivalent fractions, so we are going to get hypotenuse equals to 8 times 1, 8 over 0.60. So 8 divided by 0.60, we're going to get 13.3. 13.3. So the hypotenuse is 13.3. There is another idea that you can use. I'm going to use it later on in the upcoming questions. That, remember, we study a theorem in previous graders under the title of Pythagorean theorem. So it works for right triangle in order to get the sides, the length of the sides. We are going to see it in the upcoming questions. Okay, there is another one, 25 here. So just find this one. This is the same thing, the same idea. Regarding to 25, so I'm going to say that tan 25 equals to opposite for 25. This is going to be opposite, and here is going to be the adjacent. So 3 over adjacent. 3 over, let's say, KL. All right, tan 25 equals to 0.46. 0.46 over 1 equals to 3 over KL. So make a cross product. KL equals to 3 over 0.46. After simplifying, I hope that you can simplify this by yourself. I just skipped a step here. So at the end, you are going to deal with KL equals to 3 over 0.46. So 3 over 0.46, which is 6.52. So adjacent is equal to 6.52. Okay, so use another trigonometric ratios to find the hypotenuse. So I'm going to go with sine, or you can just go with cosine. If you go with cosine, you need to use this number, this side, but I'm going to go with 3. It's easier than dealing with decimal number. So sine k, which is sine 25, directly I will write sine 25 equals to 3 over the hypotenuse. Sine 25 equals to 0.42. 0.42 equals to 3 over h. Give a denominator 1, cross product. After simplifying, hypotenuse equals to 3 over 0.42. So 3 over 0.42 equals to 7.14. So that side is equal to 7.14. Always hypotenuse must be bigger than the legs. Otherwise, you did a mistake. Perfect. Okay, find the length of the side. I will just leave this question for you. You can just do it. 53, so tan 53 equals to 6 over this side. You are going to find this side. Then use sine 53 equals to 6 over the hypotenuse. You can just find it out by yourself easily. Okay, the second idea is about domain and range of the trigonometric function. The first one is sine x. Well, regarding to the graph of the sine x, the graph is in this way. And as you can see, the graph goes through 0, 0. Why? Because sine 0 is equals to 0. That's why the graph should go through the origin, which is 0, 0. And the way of the graph is just waving like this. As you can see, the graph from right, it goes to positive infinity, and from the left, it goes to negative infinity. That's why domain of sine, I will just write domain is from negative infinity to positive infinity, or in another word, we can say all the real numbers. But the range is, as we said, domain related to the x-axis, which is left and right, and range related to the up and down, which is y-axis. So from based on this graph, as you can see, the graphs, the parent function, by the way, we are talking about this function, which is, y equals to sine x. So the parent function is between two numbers. It's from -1 to +1. It didn't actually goes down like lower than -1. It exactly, because sine negative pi over 2 is equal to exactly -1. Sine pi over 2 equals to 1. We said that pi equals to 180. You can just try it. 180 divided by 2, 90. Sine 90 equals to +1. That's why range is from -1 to +1. Take care of this. Perfect. This is the graph of the sine x. The next one is the graph of cosine x. We have got the same story regarding to domain and range, but the graph is a little bit different. Take care of it. It didn't go through origin. Why? Because cosine 0 equals to 1. Cosine 0 equals to 1. And as you can see, this is the way. So in grades 11 and 12, of course, you are going to see, you are going to study something else regarding to the graph of these trigonometric functions. For the videos, like grades 11's books video, I will just explain everything regarding to the remaining parts of the graph of the trigonometric function. But for now, this is the only thing that you need to know: domain and range, and the way of the graph, of course. How does it behave? So domain, again, since it goes to the positive infinity from right and it goes to the negative infinity from left, so domain is all the real numbers. And range is, again, between two numbers, -1 and +1. Cosine of 0 equals to 1. Cosine of pi equals to -1. So it's from -1 to +1. Be careful, we are talking about the parent function. Because right now I'm going to just give you a note that it will change the story of the range. Okay. Before I actually go to the next slide, I will just give you that note. Simply, we can say that f of x equals to either b sine x or b cosine x, then domain is always all the real numbers, don't change it. We have no problem with domain of x, sine x and cosine x. But the range would be from -b to +b. Be careful. Whatever is this b, so the range will be from the negative of that b to its positive. Imagine we have got cosine like 10 cosine x. So the range would be from -10 to +10. Take care of this note. Don't forget about it. And then last graph, which is the third one, is the graph of tan x. Something is interesting regarding to tan. Remember, we said that domain related to the x-axis and range related to the y-axis. Clearly, you can see that for the range, the graph goes down to negative infinity and it goes down to positive infinity. Of course, it made up, like the graph of tan made up of like different parts. There is something that it's not, like it is not okay with it. Right now, we are going to just find it out. It's a kind of point. So regarding to the tan, range is all the real numbers. Don't forget this. Range is all the real numbers. But domain is also all the real numbers, but except some points. What kind of point it is? Look, pi over 2, 3 pi over 2, negative pi over 1 over 2, negative 1 pi over 2, negative 3 pi or pi over 2. That's why, as if you just take a look at these numbers, the coefficient of pi over 2 clearly, you can see that they are the odd integers. 1, 3, pretty sure the next one is 5, then 7. So they are odd multiples of pi over 2 from the left side as well. Negative 1, negative 3, so negative 5. So therefore, all the real numbers minus odd integers of pi over 2. Or we can say that odd integer multiples of pi over 2. Okay, for instance, so pi over 2, we said that it equals to 90 degrees. So 190, just go and press it, enter it into the calculator. Look, tan 90, math error, which doesn't exist. And okay, 3 times 90 is equal to 270. So tan 270, math error, doesn't exist. I hope that you can see it. Yes, so since we have got math error, it means it doesn't exist. So, but in any other point, rather than like the odd multiples of pi over 2, absolutely tan exists, and it has no problem with any other point. So that's why we can say that domain of tan is all the real numbers except odd integer multiples of pi over 2. Keep this in your mind. Whatever we said in these 3 slides, all about it is here. Okay, this is the graph of sine, graph of cosine, graph of tan. Domain is all the real numbers. Cosine, for the cosine domain is all the real numbers regarding to the parent function. Range is from negative 1 to 1. Range is from negative 1 to 1. And for the tan, we have got domain, all the x's except the k pi over 2 when k is an odd integer. And range is all the real numbers. Don't forget about this. Perfect. Now, there is a note. It says that the sum of the interior angles in a triangle is 180. But because our triangle is 90 degrees, so the sum of the other 2 acute angles are 90 degrees. So in a right triangle, one angle is 90. And we know that the sum of the interior angles in a triangle is 180. So how much will remain? 90 degrees. For what? For the remaining 2 acute angles. Perfect. If in a right triangle, at least 2 lengths of the sides are known. If we have got 2 known sides in a right triangle, we can find the measure of the acute angles by what? By using inverse trigonometric functions. So inverse trigonometric functions. When we have got 2 sides in a right triangle, we can use the inverse trigonometric function in order to find the measure of the acute angles. Right now, you are going to see how. There is an example here. I don't want to just go and explain it with this example. There is a beautiful example here. It says, by using a calculator, find the measure of the angle M and then find the length of the hypotenuse. As you can see, there are 2 known sides. The legs are given. We already said that if the legs are given, we are going to use tan. But if the hypotenuse and one leg was given, so we are going to use sine or cosine. It depends on the given leg. If it is opposite, sine. If it is adjacent, go with cosine. So here the legs are given, so we are going to go with tan. We will say that, okay, tan M equals to 2, opposite over hypotenuse, which is 4/6. Now, in order to find the measure of this angle, because we are looking for the for the angle M, so we need to turn this one to inverse, tan inverse. Whenever we turn the trigonometric ratios to their inverse, we will switch the place of the result and the angle. How? This 4/6 is going to come inside, so 4/6. And then M goes out. So M, angle M. This is exactly what we are looking for, the measure of angle M. So it's equal to tan inverse. How are we going to calculate it on calculator? So please shift and tan. So it's going to automatically give you tan inverse of 4 divided by 6, close bracket. So it's going to give you 33.6, which is 33.6 degrees. So here is 33.6. You can just round it up to 34. So if you just round it up to 34, here is 90, here is 34. So 90 has gone already, 90 will remain. 90 minus 34, 90 minus 34, 56. Why do I use calculator? 56. So 90, 34, 56. If you find out one of them, the other one is going to be clear based on the sum of the interior angles in a triangle. And as well as it asks about the hypotenuse, find the hypotenuse. Here is the thing that I told you, we have got two ways, either using trigonometric ratios to find the hypotenuse or Pythagorean theorem. Well, I strongly suggest you go with Pythagorean theorem. So it says that in a right triangle, the sum of the legs square, so 4 square plus 6 square, always equals to hypotenuse square. What is the hypotenuse? We don't have it, so we are going to write h square. 4 square is equal to 16. 6 square equals to 36, equals to h2. 16 plus 36, it equals to 52, which is h square. So take square root for both sides. H approximately equals to square root of 52, which is 7 point, let's say 2 or 3. Let's go with 3. Well, let me just calculate it. Square root of 52 equals to 7.2, like almost 7.2. So the measure of the hypotenuse is equal to 7.2. As we already mentioned, that hypotenuse always must be bigger than the legs. So as you can see, the legs are 6 and 4, but the hypotenuse is 7.2, which is bigger than both of them. This is how we find out the measure of two acute angles when we have two sides, and of course the length of the hypotenuse by using inverse trigonometric function. There is another example here. Okay, this one, question 11 in your exercises. It says the same thing, but the hypotenuse is given. Right now, it depends on you which angle you want to work on it. Either B or A. Well, I'm going to go with B. Okay, you can go with A. In that case, for A, this is going to become opposite, so you should go with sine. But if you go with B, you're going to go with adjacent, so which is cosine. So I'm going to write cosine B equals to cosine B adjacent over the hypotenuse, which is 4 over 6. So in that case, we need to turn our trigonometric function to its inverse. So cosine inverse. When we turn the trigonometric function to its inverse, the place of the angle and the result will definitely switch. So B is going to come out, and 4 over 6 goes in, equals to angle B. So cosine inverse, press shift, cosine, and bracket 4 divided by 6. It's going to give us 48.1. So B equals to approximately 48 degrees. So if here is 48, how much will remain for here? So we are going to say that 90 minus 48, it equals to 42. So here equals to 42 degrees. Okay. Okay, so 42 and 48, come in please. 48 and 42, these are the angles that we need to use inverse trigonometric functions to find them. How about the length of the side that it is not given, which is this side? Let's just name it as x. How are you going to find this x? Pythagorean theorem. As I already said, that the best idea to find a missing length in a right triangle is just using the Pythagorean theorem. What does it? He said, he says that the sum of the legs square, which is, so this leg is what? 4. So 4 square plus, do we have this one? No. So x square equals to the hypotenuse square, which is 6 square. So 4 squared is equal to 16 plus x squared, we don't have it. 6 squared is equal to 36. How do we do this kind of question? So move this 16 to the other side. It's going to become x squared equals to 20. Right? Take square root to remove that square. So x equals to square root of 20. Square root of 20, it's between 4 and 5. So you can just keep it like this. Or if you were wondering what is it equal to, you can just say that, okay, square root of 20 equals to 4.4. Equals to 4.4. This is how we are going to find out the acute angles by using inverse trigonometric function and how to use the Pythagorean theorem to find out the length of a side. Okay, welcome. The next one, I will just leave it. You can just do it by yourself. We just solved 2 questions regarding to this. The legs are given. The legs are given. So we are going to use tan muhannat. So since the legs are given, we will use tan b. You will say that tan b equals to 2 over 2 square root of 3. The 2's are going to cancel each other. 1 over square root of 3 will remain. So tan to tan inverse. We just solve it. Shift tan inverse. Open bracket 1 over square root of 3. Well, it equals to exactly 30, which means angle B is 30. Basha, agar angle B is 30 and our 90 there. So how much will remain for here? 60. So we found the angles and the hypotenuse. I'm not going to solve it. You can just use the Pythagorean theorem. Let's go to the next idea of this lesson, which is something regarding to this diagram, this chart. Well, you know that a coordinate plane consists of like 4 quadrants. First quadrant, second one, third one, fourth one. All right. So here it says that angle in standard position. Basha, what kind of angle are in standard position? What conditions does an angle needs to be in standard position? In fact, it needs 2 conditions. First of all, the vertex of the angle should be in the origin. It should be in the origin of our coordinate plane. And as well as it says that the initial side must lays on like what? The positive half of the x-axis. So 2 conditions. The vertex should be in the origin and the initial side lays on the positive half of the x-axis. As you can see, every single angle has 3 parts. Vertex, initial side, and terminal side, by the way. We just turn the initial side and get the terminal side. We don't care about the terminal side for angle in standard position. So here is the initial side. As you can see, it's exactly on the positive half of the x-axis. Here is the x-axis. And the vertex is this point that join these 2 sides, which is the initial and the terminal one. It's in the origin, and the initial side is on the positive half of the x-axis. So the second note is, in the first quadrant, all 3 trigonometric ratios are positive. Regarding to this note, I hope that you can read it by yourself. There is a beautiful quote, okay, that it is actually in my own language, which is Kurdish language. That the quote is saying that hastek. You can use it. I got it from a respectful teacher. I don't want to name him, but he just used this this quote, in order to memorize these notes. So H, which is he, stands for all the trigonometric ratios. In our language, we call it hamu. All the trigonometric ratios are positive in the first quadrant: sine, cosine, tan. S stands for sine. All right. So in the second quadrant, only sine is positive. T stands for tan. So in the third quadrant, only tan is positive. K stands for cosine. In the fourth quadrant, only cosine is positive. Keep this one in your mind. Okay, the idea of reference angle is an important note here. If the direction of the ray, there is a very beautiful note, by the way, over here that we need to take care of it. If you rotate clockwise, the measure of the angle would be negative. But if we move anti-clockwise, or we can say counterclockwise, the measure of the angle would be positive. Okay. Yani, remember that circle that's right before this slide we had it. If our circle is something like this, if we move anti-clockwise, this is anti-clockwise, by the way, consider it as a clock, and this is clockwise. So for anti-clockwise, the measure of the angle is going to be positive, but for the clockwise, the measure is going to be negative. And I hope that it is understandable. All right. So regarding to the reference angle, these notes are important. Yani you can just write it down, but I will just make it more clear by just going through the questions. This is my own explanation. So, if theta, we call this letter theta, it's a Greek letter. If theta is given, there will be two cases. First one, if theta was between 90 degrees and 270 degrees. Remember? So we are just going to define what? Reference angle. Reference angle has two conditions. It should be acute. At the same time, it should be positive, the measure of it. So it should be acute and it should be positive. Keep this one in your mind. All right. So there will be two cases. Those given thetas that are going to that we are going to face mostly are going to be from these two cases. If the theta was between 90 and 270, the reference angle is equal to absolute value of 180 minus theta. Absolute value is just for making it positive, and 180 minus theta, it's going to make it an acute angle. No. What if the angle was between 270 and 360? In that case, the reference angle would be absolute value of 360 minus the given theta. Bash, mister, what do you mean by this? Let's just follow me here. Not black one actually, blue one. Okay, so 245. 245 is the given theta. So for which case of these two cases? It's definitely less than 270. So it's for the first case. In that case, we need to just say that, okay, 100, absolute value of 180 minus 245, which is absolute value of negative 65. What is the job of absolute value? Make the thing inside it positive. So the reference angle equals to 65. As you can see, it's acute and positive as well. Negative 97. You might ask me, teacher, you didn't discuss about negative angles. Tamam. Yani, whenever we have got negative angles, ignore the negative sign. So right now, imagine there is no negative. So 97, it's for this case. Therefore, the reference angle equals to 180, absolute value of 180 minus 97. So it equals to clearly 83. 83 is acute. At the same time, it is positive salah. Okay. How about 315? 315 is in this case, in this domain, which is from 270 to 360. In that case, we're going to say that the reference angle equals to 360 minus the given theta, which is 315, which is like, it equals to, any idea? 45. Acute and positive. The last one, 125, is for the first case. So absolute value of 180 minus 125, which is 55. So it's equal to 55. And the last one is another tricky example. If the angle was less than 90, it's gonna become the reference angle itself. Yani the reference angle for this 45 equals to itself. Tamam? So there are two cases and two notes actually were there. One of them was if there is negative, ignore the negative. And if the angle was less than 90, so it's going to become the reference angle itself. That's all about reference angle salah. So the next slide is a bunch of examples regarding to the reference angle. Well, reference angle of 135 is for the first case. 180 minus 135, it equals to 45, right? Yes. You want to evaluate my calculations here? The second one is with negative. Ignore the negative. 100 is between 90 and 270. So what was for that case? 180 minus 180. So the reference angle for this angle is 80. How about 350? Clearly, Akam, 360 minus 350 is equal to 10. And what is the number of Kylian Mbappe's uniform? 10. 215, so 215 is for the first case, which is 180 minus 215, 35, right? 35. So look, from 180 to 200 is 20, 20 plus 15, so 35. And the last one, 85, we said that if the angle was less than 90, the angle itself is going to become the reference angle, which is 85 here. Got it, Salah? Perfect. The next slide, we have got the units of angle. The units of angles, well, we can measure angle in two different units. One of them is degree, that we already got familiar with it from the previous grades. Whenever the angle is going to come, the word of angle, so immediately the word of degree as well comes with it. Because whenever we measure an angle, we say that 25 degrees, 80 degrees, 90 degrees, 180 degrees, Salah degrees, and this kind of stuff. But here, we are going to add one more unit, that it is called radian. The second is the circular measurement, where the unit is called radian. Whenever the radian, the unit of radian is going to come, immediately pi should come to your mind. Pi. Because in the units of radian, we have got pi at the end. Perfect. So each revolution, each spin consists of 4 quadrants. The first quadrant is from the first quadrant. Remember the circle again. So each quadrant, each revolution consists of 4 quadrants. So the first quadrant starts from 0 to 90. The second one from 90 to 180. The third one from 180 to 270. And the last one from 270 to 360 degrees. So basically 0 and 360 have got the same place. Right? We call these angles quadrantal angles. Basha Salah? We call these 5 angles quadrantal angles because they are going to just differentiate the quadrants. Perfect. Okay, what do we have in the next slide? We have how to convert degree to radian and vice versa. Bash. Keep this one in your mind. You can just take a photo of it and just transform it to your notebook in case if you want to just go in this way. But I will directly go to the question, and during the question I will teach you how easily we can convert. But there is something here. It says that a complete revolution in terms of degree equals to 360 degrees. Remember, recently we said that a full angle equals to 360. Why? Because it was a complete revolution. Perfect. But here we will say that in terms of degree, a complete revolution is equal to 360. But in terms of radian, a complete revolution is 2 pi. Why? Remember in the beginning of the lesson we said that pi equals to 180. So 2 times 180 equals to what? 360. Right? So they actually are equal to each other. Perfect. Great. So right now, let's just find out how are we going to convert degree to radian and vice versa. So if the degree was given, Danas, if the degree was given, always multiplied by pi over 180. Always multiply the given degree by pi over 180 in order to turn it to radian. So always pi will stay. Our pi hamisha dameneto. The thing that right now you have to find out is what is 30 over 180. Please don't use calculator. Simplify. The zeros are going to cancel each other. So 3 over 18 will remain. Can we simplify these two numbers more? Absolutely yes. By what? By 3. 3 divided by 3, 1. 18 divided by 3, 6. So basically it equals to pi over 6. So the point is, when the angle is given, multiplied by pi over 180. That's all about turning degree to radian. How about the vice versa? Easier than this. If the radian is given, so consider pi as 180 over 3. Bash 180 over 3 equals to what? 60 degrees. So from radian, we turn to degrees. Okay, again, degree is given. We said we are going to multiply by what? Pi over 180. So multiply by pi over 180. Pi will stay because we are going to turn it to radian. And in radian unit, we have got pi. What will remain? 0 will go with 0. 9 over 180 will remain. Oh, sorry. 18 will remain. So 9 over 18. Clearly, it's clear that we can simplify it. Right? By what? By 9. 9 divided by 9? 1. So 1 pi over 18 divided by 9? 2. So basically it equals to pi over 2. You need this angle a lot. A lot. You have no idea how much you are going to face it in the future, inshallah. So 90 equals to pi over 2. And how about the last one, Salah? Pi over 5. Instead of pi, we are going to put 180 over 5. 180 over 5? I'm pretty sure you want to say 36 degrees. So 180 divided by 5, 36 degrees. Right, Anas? The next slide. We have time? Yes. Degree is given 45. So if the degree is given, what do we need to do? Multiply by pi over 180. Pi will stay. So the question is, 45 and 180, can we simplify them by a common factor? Yes, by what? By 3, by 9, by 45 itself. Always choose the greatest common factor. Salah said by 3. You can go with 3, but you need more step. But I'm going to go with 45. 45 divided by 45, 1. 180 divided by 45, it equals to 4. Therefore, the result equals to pi over 4. Basha? The next one is pi. So pi, clearly it's equal to 180. That's it. It's famous. We already said that. Pi equals to 180 degrees. 120 degrees multiplied by pi over 180. We said pi will stay. 0 goes with 0. 12 over 18. So 12 over 18. So 12 over 18. We are going to just simplify 12 and 18 by a common factor, which is, so here 6 is the best option. 12 divided by 6, it equals to 2 pi over 18 divided by 6, it equals to 3. 2 pi over 3. This is how we change from degree to radian. All right. And how about 2 pi? So it's clearly 2 multiplied by 180. So 2 multiplied by 180, it equals to 360 degrees. 360 degrees. That's it. So this is how we convert from degree to radian and vice versa. The last type of question that you can all do it by using trigonometric ratios. We can just use by using actually calculator, not trigonometric ratios. So cosine pi over 4. So easily you can say, okay, 180 divided by 4, it equals to 45. Then what it ask about? It asks about sine of it. So press sine. It's going to give us 0.70. So it's equal to 0.70, or it equals to its famous square root of 2 over 2. These are, both of them are acceptable. One more example, 2 pi over 3. So 2 times 180 divided by 3, 120. So cosine, press cosine, it equals to negative 0.5. Negative 0.5. How about the last one, 3 pi over 4. 3 times 180 divided by 4, it equals to 135. What does it ask about? Tan. So press tan, it equals to exactly negative 1. Negative 1. 3 pi over 4, substitute, tan equals to negative 1. Yes. One more slide left that I hope that this video actually is long, but it was all about trigonometric ratios, functions, and there were like different ideas, variety of questions. That's why it was like that much long. The last one, I will just solve this B, and I will leave A and C for you. When you had exam, you can just try them out by yourself. So 5 pi over 6, 5 times 180, 900, divided by 6, it equals to 150. It says cosine, so press cosine. It's going to give us negative 0.8. Negative 0.8. And I hope that this is clear and you got everything. Inshallah, I will see you in another video. Take care of yourself. Thank you.